Hello and welcome to our video today. So we shall be doing more balancing and hopefully you'd be able to master this one. I'll be using some other problems and then I think I'm adding another concept because I wasn't able to tackle this in the last video. So first let's look at this one. Whenever you try to solve or try to balance rather, when you try to balance equation, um remember that this is a trial and error type of balancing. It's okay that you will not get it right the first time. You will change, and then you'll come up with your final answer. So remember, step one is going to be writing down all of the substances involved. So for example, you have U, F, H, and O. So if you look at you look at the reactant side, you have U, you have F, you have H, and you have O. So same is true with the product side. However, if you look, this is F, okay. So if you look at the product side, it looks a little bit different. So because you will have 2F right there. So for example, we're going to count the number of substance now per side. So for the reactant, you have 1 uranium, you have 6 fluorine, you have 2 hydrogen, and then you have 1 oxygen. Another thing that you can do now is count the product side. So how many uranium? You have 1, then you have 2 oxygen, followed by 2 fluorine, and then 1 hydrogen, and then another fluorine. So this becomes 3. Okay. Now, if you look at this, the only thing balanced is your uranium. The thing that you have to do first is try to notice which compound, if you change them, will affect a lot. So for example, if you change this, okay, if you change the coefficient of this, you will affect uranium, oxygen, and fluorine. So the focus here is to try to make sure that the change will make it easier for you to balance. So one of the things that you can focus on is try to balance some other groups first. So for example, your oxygen, since this is just 1, okay, so this is 1, 1, and 2. You're going to try to make sure that your coefficient is low as possible, okay? But if you can't, you can exceed more than 10, but if you can, try to make sure that you would still be at the minimum, like 2, 3, 4, 5, at that number. So for example, the greatest common factor between 1 and 2 is just 2. So to balance the oxygen, I'll just have to change the coefficient of this side. So change it to 2. So 2 times 2 of your hydrogen becomes 4. Your hydrogen becomes 4. 2 times 1, your oxygen becomes 2. So that's good. Your oxygen is equal already. However, there's other changes that are very visible. Now, your oxygen and your uranium is pretty balanced. However, your hydrogen and your fluorine is still not balanced at all. So all you have to do now is look at the product side because the product side is at a lesser number. But if you notice, you could actually balance it now by changing this coefficient because since hydrogen and fluorine is combined in this molecule, by changing this, you'd be able to come up with an answer that would balance both of these substances. So for example, you want H to become 4, so all you have to do is use 4. However, you have fluorine, which is 1, so if this becomes 4, can it be balanced with your fluorine on the reactant side? Well, yes, because your fluorine right here in your product side is 2 and 1. So, by changing this to 4, 4 times 1, your H becomes 4. Your F or your fluorine becomes 4. So, 4 times 1, this becomes 4. Your fluorine is going to be 2 plus 4, then you'll have 6. That would mean uranium balance, fluorine balance, your hydrogen balance, and your oxygen is balanced. Yes. So that's how you solve our first equation for today. The next. Okay. So for this one, I think this is a new part for everyone because you are going to have a parenthesis. So this is something new. However, just think of it like a math thing. Let's try to count down first all of the elements involved. So we have here sodium, you have carbon, you have oxygen, you have magnesium, and then you have nitrogen. Okay. So a reminder, I think some of you might have a little bit of confusion maybe because when we were in high school, this was a confusion for some of my classmates too. So these are two separated compounds. I mean substances. These are two separated substances. N is separated from O. Okay, so let's do the counting. Let's start from the product side because this is much easier to count first. So magnesium is going to be 1. Your carbon, it's 1. It's not a part of the 3. So carbon is 1. Your oxygen is going to be 3 on this side and 3 on the other compound. So that makes 6 oxygen. Next, sodium is going to be 1. And then your nitrogen is going to be 1. Now, we've counted all of the product side. Now let's count the reactant side. So first, let's start with sodium. Sodium is 2. Carbon is 1. Oxygen is 3 for this molecule. Now for magnesium, you have here Mg, so it's still 1. The next would be nitrogen and oxygen. So for nitrogen and oxygen, it's going to be different. So just use the distributive property of in parentheses. So if you have a subscript outside, okay, all of the elements in the subscript will be multiplied by that subscript that is outside the parentheses. So this will be 2 times 1. So your nitrogen here is going to be 2. 2 times 3, this is going to be 6. So 2 times 3, you have 6. 6 plus 3, the number of oxygen is going to be 9. Now, how do we balance this? So if you look and see, the main concern is going to be sodium and oxygen and nitrogen. So do you have any equation that will affect those three? I mean, do you have any compound here that could affect those three right away? So this side is the one that's going to be affected right away. We have sodium, nitrogen, and oxygen. Now, the only thing that I can see, okay, is that sodium needs another sodium, and then nitrogen needs another nitrogen. So the best number to use here is 2. So actually, one of the best ways to do balancing is maybe you should start with you start with 2, then you add 3, 4, until you get to the number that you desire. So 2 times 1, it's going to be 2. Your sodium becomes 2. 2 times 1, your nitrogen becomes 2. 2 times 3, okay, your oxygen becomes 6. And then since you have an oxygen also on the other compound, so 3 plus 6, the number, or the total number of your oxygen is going to be 9. So that's how you solve this equation. So this will be 1, 1, and 1. By the way, some equations can be balanced already. You don't have to rush and into balancing them every time. Okay, so